We are here with Mark Baker, which is a lead developer at Paybrake, which is a fintech company based in Manchester, UK. He's been working in computer software industry since before symbolicscript.com was registered as a domain name, before the cyberspace term was used in science fiction when Linus Torvalds and Rasmus Ledorf were still in high school and Mrs. Zuckerberg had yet to give birth to a baby social network enabled. He has been developing for the web in a variety of languages since the days when the Tim Berners-Lee creation comprised less than 1,000 sites. Over the years, has contributed to a number of open source projects, some still existent, others lost to history, including a minor submission to PHP SPL. Currently, he is a coordinator, a lead developer of the PHP Excel library, and a coordinator and developer of the PHP Office library suite. Most recently, he has been working on new data structures, and he is hoping that he'll be able to add them to the SPL. His particular interests include PHP integration with Office suites, generators, data structure, textual analysis, geodata, and geographic information system. So welcome, Mark. How are you? All fine?
Thank you very much, Alessandro. I'm well, although just as a correction, I've been at an Amsterdam-based company in communications for the last 2 years. So I'm an exile from Brexit. I prefer to be European.
Okay, that's a good choice then. I also heard that you are a creator of Amphis, the PHP elephant that was sold on PHP Day in the last years.
That's correct. Yes.
That's good. That's good to know. But I also heard a rumor that you're working on another elephant. So we are all waiting for that.
Well, it's a rumor at the moment, but it looks as if I might be creating twins.
Oh, that's nice. Well, thrilled to see them then.
Yeah.
Okay. So the stage is all yours.
Thank you very much, Alessandro. I'm here to talk to you today about SPL, and most specifically SPL Iterators. For anybody that's ever looked at SPL Iterators in the documentation, it's rather off-putting. There's just so much there. It's difficult to understand, difficult to know what to use and when it should be used. But hopefully I'll at least give you some ideas of some of the more interesting iterators available within PHP and how and when they might be used and how they can improve their code if you do use them. Well, when I was writing this talk, the first thing I did was I went to Wikipedia and I said, what is an iterator? And it came back with, well, it doesn't actually mean a great deal to most people. An iterator is an object that enables a programmer to traverse a container, particularly lists. Okay, to put it into context, and it's some real code that you'll probably understand. You're probably familiar with this particular type of structure for looping over an array. It's extremely clever and powerful. It'll just loop over each element within the array, give you access to the key and or to the value, and allow you to do something with them. Strictly speaking, an array isn't an iterator, although it is iterable, but PHP also provides a large set of iterators that work in exactly the same way. So I can take the array that I've got here, which yields that result, wrap it up in an iterator, and use exactly the same for each loop to loop over it, accessing the values, accessing the keys in exactly the same way as I do with an array. The big difference is that the iterator is an object. I get exactly the same output when I try to use it. An iterator is basically an object that allows us to loop over it using a for each loop in the same way as we would with an array. If you can see the example on screen, using an array, a very simple piece of code which generates that output. We can wrap that array within an array iterator. We now have an object for data set, an iterator object, and we can use a for each loop to iterate over it in exactly the same way as we did our array. Same output. Under the hood, it's doing something a little bit different. The iterator interface provides a number of methods that must be implemented if you're creating your own, but SPL does provide a lot of built-in iterators which implement this functionality. What the array iterator is doing underneath the hood is it executes a rewind to set itself to the beginning of the iterable data. And then, as long as it's got a valid entry, it provides access to the key and to the current value. And then within the loop, it moves on to the next entry. You can actually call these methods directly as you're working. But using a for each loop is a heck of a lot easier to work with. Array iterator is just one example, but it demonstrates a lot more than just being able to use a for each loop. That's the output we would get from it using a for each. We have this interesting little tree of what is iterable, what is traversable, and what is an iterator. Both an array and a traversable are iterable. You can for each over your array, you can for each over any traversable, which means you can use a for each loop over an iterator aggregate, and a generator. But already we're getting kind of lost here. What is the difference between all these? Well, not all iterables are equal. You can, for example, count the elements in an array, but you can't always count the elements in an iterator. You can access the elements of an array by their index value, but you can't always do that with an iterator. You can rewind an iterator. We've just seen an example of that with array iterator providing the rewind method. But a generator is also an iterator. You can't rewind a generator. Well, maybe we'll come to that if we've got time. There's also a set of iterator functions, such as iterator to an array. Do these work on all iterators? Well, can we use them with Iterator Aggregate, for example? Okay, let's look at some real code. You might have code like this in a repository. Simple query which returns a list of all the users, and what we're returning is an array of user objects. We do the select, we execute it after preparing it, we implement a fetch all, and we then just map each entry of that to a user object and return the array that we get. But there's a few problems with this approach. We're type hinting it to an array. So if we want to be a bit more semantic and tell the IDE what we're doing, we need to provide a return block to specify it's an array of user objects. Well, there's a way we can be a bit more semantically clean for that. We can return an array iterator instead. We extend array iterator, give ourselves a user list as a class name. Now, we get into the realms of countable, array access, serializable, and seekable iterator in a moment. But now we return a user list. we're being a lot more clean semantically than simply returning an array. So what were those little things? Array iterator implements countable as well. That means we can actually do a count in the same way we would do with an array. Or we can actually use a count method if we want to use OO code when we're working with it. And we get the results. So array iterator does a little bit more than simply iterate. It implements array access. So we can actually access individual elements. Here is an example, in accessing user list 2, the third element, 0, 1, 2. Yeah, so we're accessing. However, note that it's a serialized object, not a serialized array in this case, but we can still do so. And then we unserialize when we pull it back from cache, and we've got the same results. And it's seekable. That's something you don't see with a normal array. What we can do, because it's an object with the seek method, is seek for the element at offset 2, and then loop from there. So we get just elements 3 and 4 in a loop in this case. So using seek, we can actually select a subset of the elements from that array iterator. So that's a few of the things that are implemented already in SPL Standard Array Iterator. There's more. It provides a load of methods for sorting, including NatCase sort, UA sort. We just have to access them using the methods rather than doing them directly. The sad thing is, as with all iterators, you can't use the array functions with them. Although it's not that difficult to set up your own functions for things like mapping, for filtering, and even reduce. Then we get to all this mass of iterators that SPL actually provides. It's a long list, and you can get into the iterator to get a drinking game. Have a few drinks and then trying to list them all. Append iterator, array iterator, caching iterator, callback filter. It's quite a tongue twister, especially when you get to the iterator and the recursive iterator, and so on. But let's have a look at a few of those and see which ones might actually be useful. Start with a simple array. And in this case, I am implementing the array access user list that I've already created, but wrapping that within a limit iterator that starts at element or element with offset 2, and then doing the for each. What I actually get when I do this is the equivalent of seek. Elements from offset 2 and offset 3, user 3 and user 4. So I can actually nest iterators. I can provide an iterable object to any iterator and nest them. So our array iterator is nested inside a limit iterator. I can provide start and length to iterate over as well. So the equivalent of an array slice. We've got a fancy one here. Something that you can't actually do with a standard array is loop over it repeatedly within a for each loop. But if I implement an infinite iterator, it will keep looping that for each loop until I tell it to stop with a break. So a simple count of the days of the week, using the limit iterator to tell it what day to start at. It's Tuesday today, so we want to start at today offset to Tuesday. And it will just keep looping Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, until I tell it to stop. So we're using a counter just to give us 14 days, 2 weeks, and then we're breaking out of the loop. And that's what we would get, 2 whole weeks. Another level of nesting using a callback filter iterator here. In this case, I only want to pick up on the actual work days, Monday through Friday, and ignore Sundays and Saturdays. So I'm using a callback function to return a false if it's a Saturday or a Sunday, and a true if it's any other day. And now when I loop over, well, I've set the counter to 10, so it'll only work 2 weeks ahead, but it'll only give me working days during that 2-week period. So if we want to work with calendars, it's quite a useful little technique. So as you can see, Tuesday, Wednesday, Thursday, Friday, Monday, Tuesday, Wednesday, Thursday, Friday, Monday. 10 days, work days only, starting from Tuesday. And I'm actually nesting 4 iterators here. It's pretty clean, it's pretty intuitive. All of them have fairly well-defined names to explain their purpose, but I can implement a lot of fairly complex code, iterating code, very, very simply, easily, just by nesting like this. That allows me to do all manner of things. I can use callback filter iterator here, but I could equally have used a regex filter iterator. And using a regex filter iterator and something like the file system iterators, nesting them together gives me a very good way of identifying image files and listing all the image files in a directory. Let's go back to our user list. One problem with this user list is the fetch all. It's very, very expensive in terms of memory if I have a lot of users in the database. That's when I might want to use something like a generator, so that we're only actively working with one user record in memory at the same time as we loop over them. Instead of doing the fetch all to get all 10,000 users from the system that uses half a gigabyte of memory, I'm returning one at a time. And we're returning a generator from the all function. That doesn't tell me a great deal when I'm working with my IDE about what type of generator it might be or what the generator might return. Again, PHP doc blocks with an at return block will allow me to at least tell the IDE what's being returned. But what I'm going to do here is re-implement my user list using Iterator Aggregate this time rather than an array iterator, and inject the PDO statement as into the constructor and implement my while loop and the yield within a specific method, the only method that Iterator Aggregate requires, getIterator, which will return a traversable. So with this, I can then implement my user repository code or method to return a nice semantic user list, passing in the statement. Now, one particular thing to note here is that I'm taking the prepared statement and I'm doing the execute inside the Iterator Aggregate. You say you can't rewind a generator, but if I wrap the generator in an Iterator Aggregate like this, it simulates rewinding the generator, because I can for each loop over user list, and then I can for each loop over user list again. This time, it will work. It won't with a normal generator, but because I'm re-executing the statement here, and then looping over the results yielding them, it will re-execute the statement. So I'm simulating a rewindable generator using Iterator Aggregate. That's kind of useful sometimes. Maybe not so much with a database, where if someone goes and adds another user to the users table, the second time I iterate over, I'll have a different number of users. But if you're doing remote access to making calls to pull set of JSON exchange, a set of exchange rates as JSON or something like that, then it can be rather useful to be able to iterate multiple times and still yield from a generator. And that's possibly a useful trick to pass on. Yes, you can rewind generators if you work in that way. Now, we're close to what should be time for this, and although we had technical problems earlier, I don't particularly want to go over time over much, but I'm just finishing with a few links. I have blogged about some of the clever tricks here that you can do with iterators, such as generators. Functional Guide to Cat Herding is demonstrating techniques for applying map, filter, and reduce with iterators and with arrays, explaining how those can work. Filtering and mapping, again, very similar. Parallel looping. One of my all-time favorite iterators is the multiple iterator. There's a blog post there if people do want to read further and look at some of the other things that iterators can do for you. And there's a couple of very good books on the topic as well. Cal Evans has written Iterating PHP Iterators, which describes all of the iterators available in PHP in great detail. And Joshua Tyson has written a book about SPL as a whole, but which does go into a lot of detail about SPL iterators. So they're all well worth looking at if you get the chance. Now, I think we're fast approaching time, so that's it from me, and hopefully, if the technology allows, I'll be able to answer any questions that people might have.
Okay. So thank you, Mark. Thank you for enduring the technical difficulties. I think it was still hearable, so I hope all the audience understood everything. Let's
Sorry
see if we
fast run through, but I was keeping an eye on the time for the next talk.
Well, thank you for that too. Then, well, on the chat they are asking for a link for the slides. If you can provide them later.
I will provide later. They'll be up on SlideShare before the conference is over.
Okay, great. Let's see if we have any question from the audience in the chat. As always, we need to wait for a couple of seconds of delay in case. Otherwise, I'll try to ask a question myself. Do you think there's any iterator that is worth mentioning or suggesting to PHP developers to be used from the long list of SPL ones?
Well, I mentioned very, very briefly the multiple iterator, which is one of my favorites. Where you're trying to iterate over multiple arrays, you would probably do for each X over one of the arrays as key value, and then access the values from the other arrays using the index from the first. SPL's multiple iterator allows you to do that in a much cleaner way when you're talking about iterators. Even if the iterators don't have the same number of elements, you don't have to worry about that. It provides a number of different modes of working, which means it can carry on until whichever array is the longest, or whichever iterator is the longest, or terminate when it reaches the first one that doesn't have any more elements. And that I find fairly useful for combining data from multiple sources. And again, semantically, it's very intuitive when you're reading the code, what it's actually doing, and doesn't have all the overheads of getting the values from the second and third arrays. Others that I find particularly useful, I do a lot of work with file system files. So being able to use the file system iterators, particularly with the regex iterator, to give me a list of all the unit tests, give me a list of all the PHP files, give me a list of all the image files in a folder, or even recursively in subfolders as well, are particularly useful techniques if you're working a lot with files. They also return file objects.
Oh, right. Okay, so we got another question in the meantime from Michael. Are there any benchmarks or performance comparison with structures like arrays? So it's faster, it's slower, what resources consume?
A long time ago, I think it was when PHP 5.4 came out, I did some benchmarking, and using SPL iterators was noticeably faster then. Of course, with the changes in PHP 7, when arrays were redefined internally, that became a much smaller margin of difference. It's not particularly noticeable in terms of timing and performance, but overall, iterable objects are generally a lot more memory performant than arrays are.
So they are basically better for large groups of data.
That's right, and except in the case of array iterator, where you're actually storing the array within the iterator, so you've still got all this array storage in place anyway. But if you're reading from file line by line, being able to use iterators to do that is a lot cleaner than a file get contents, and also a lot more memory efficient. And allocation and deallocation of memory, if you pull it all into memory using file get contents, is quite costly in terms of time it takes. So depending on exactly what you're doing, you may find you get some performance benefit. It's marginal in most cases now with PHP 7, but there's a few iterators which do give you that boost. But you will almost certainly find that you get a lot better memory usage.
If I remember correctly, the SPL is more specialized and the array is more multi-purpose. That's probably the main difference. I remember looking over the list and having to remember CS stuff from the university to understand the differences between list and stack and all the other memory structures, to understand what was the best usages for all of them.
Yes, and there was a time when your documentation of SPL was non-existent. I know Pete Coburn has been doing a lot of work over the years trying to update that. There's still a lot missing, though. It's still not as well documented as it might be. But if you're moving into some of the other things like SPL heaps and doubly linked lists, at least you've got a better idea now. Some examples there, but it does still require maybe a bit of research or a bit of dredging your memory of computer science from university to understand them properly. And yeah,
that's
worth the
basically
effort.
my experience.
It is worth the effort. When used in the right context and in the right way, they can be a lot more powerful, memory efficient, and performance efficient as data structures. If we're going into the data structures, fixed array is an interesting one. If you want to know how much data there's going to, or if you know in advance how much data there's going to be in your array, and you're working with simple numeric increments from 0, then use fixed array because it's about 20% less memory usage and performance-wise almost exactly the same speed. But the initial allocation of memory is a big boost there.
Yeah, right, because it already knows how much memory that it needs, right?
That's right. So it just pads out the amount of memory it needs in advance, whereas as you build a normal array, it's grab a little bit, grab a little bit, grab a little bit, grab, etc.
Yeah, that's not ideal. I'm recalling some stuff from my C++ days. I can remember how painful that was when you had to manage that all by hand. So, yeah.